Next topic in this chapter is phenols. Phenols means if OH group present on benzene ring is called phenols. Those are also called aromatic alcohols. If OH group present on alkyl group, that is called alcohols. If OH group present on benzene ring, those are called phenols or aromatic alcohols. See, this is phenol. This is for that common name is carbolic acid. IUPAC's name also in that case phenol. If two OH groups are present at adjacent positions on benzene ring, that is called catechol. IUPAC's name benzene 1,2 diol. If two OH groups present at a meta position, that is called resorcinol. For that IUPAC's name is benzene 1,3 diol. If two OH groups present on benzene ring in opposite position, that is called hydroquinol. Hydroquinol. For that IUPAC's name is benzene 1,4 diol. Because this is first position 1, 2, 3, 4. Next, if OH and CH3 present on benzene ring, that is called cresol. When those two are present at adjacent position, that is called orthocresol. For that IUPAC's name 2-methylphenol. If OH and CH3 present in meta position, that is called metacresol. For that IUPAC's name is 3-methylphenol. If OH and CH3 present in opposite position, that is called paracresol. For that IUPAC's name is 4-methylphenol. Next, if three OH groups present in adjacent position, that is called pyrogalal. Pyrogalal. For that IUPAC's name is benzene 1,2,3 triol. Next, if three OH groups present in alternative position, that is called pyroglucinol. For that IUPAC's name is benzene 1,3,5 triol. So that is about introduction of phenols. Next, preparation methods. First preparation method is from chlorobenzene. When this chlorobenzene reacts with NaOH, then this HCl will be removed, then sodium phenoxide will be formed. When this sodium phenoxide again reacts with HCl, then this Na and Cl will be removed. That means this H replaces Na. Then finally we get phenol. That is one preparation method. Next preparation method is benzene sulfonic acid. That means benzene sulfonic acid means if benzene having SO3H group, SO3H, that is called benzene sulfonic acid. When that benzene sulfonic acid treated with NaOH, then H2SO3 will be removed. That means SO3H and this H, this part will be removed. Then ONA will come on benzene ring. That is called sodium phenoxide. Again, this is treated with HCl. This is to be treated with HCl, then we get phenol by losing NaCl. That is another preparation method. Next preparation method is benzene from benzene disonium chloride. Benzene disonium chloride formed on benzene ring N2Cl is present. When that benzene disonium chloride undergoes hydrolysis with slow heating, light warm, then we get which one? Phenol. And N2 and HCl are formed as byproducts. Next, from cumene. Cumene means when isopropyl group present on benzene ring, that is called cumene. This is also called isopropyl benzene. When that cumene treated with oxygen, then this oxygen is inserted between carbon and methyl group. Sorry, carbon and hydrogen group. Then we get compound, this one. When this compound undergoes heating, then this total part, this part will be removed. This part, this CH3COCH, this total part will be removed. Then phenol is formed and acetone is formed as byproduct. That is about preparation methods of phenols. Next, chemical properties of phenols. Chemical properties. When phenol 2 moles of phenol reacts with sodium metal, then we get sodium phenoxide. That means what is happened? This sodium replaces hydrogen from phenol. That means from this reaction we can say that phenol has acidic nature because sodium replaces hydrogen. Next reaction. When phenol reacts with NaOH, then also we get sodium phenoxide. This reaction also tells about acidic nature of phenol because in this case hydrogen is removed. Next, with HNO3. In that case again two reactions are there. One is dilute HNO3 and another one is concentrated HNO3. In case of dilute HNO3, see, this OH group acts as electron donating group. In HNO3, NO2 plus acts as electrophile. When electron donating group present on benzene ring, then the electrophile attack at ortho and para portion. Then we get orthonitrophenol and paranitrophenol. After them, which is more stable? Nothing but which is major product? Paranitrophenol, because in that case repulsions are very less, but in this case repulsions are more because those two groups are present at adjacent positions. Then there is a chance of repulsions, then automatically it get less stable. Next, in case of concentrated HNO3, that means when phenol reacts with concentrated HNO3, then we get 3 nitro groups at ortho and para portions. That is called picric acid. This is also called 2,4,6 trinitrophenol. These reactions are very important. So what you have to remember, when phenol reacts with dilute HNO3, then we get orthonitrophenol and paranitrophenol. But when phenol reacts with concentrated HNO3, then we get picric acid. Don't get confused about these two reactions. Next, bromine with bromine. Here also two types of reactions are present. First reaction, when bromine in CS2, when phenol reacts with bromine in the presence of CS2, then we get orthobromophenol and parabromophenol. Like as first reaction in case of HNO3. But when that phenol reacts with bromine in the presence of water, then we get a tribromophenol. That means 2,4,6 tribromophenol. This its name is what? 2,4,6 tribromophenol. In case of CS2, we get two products, orthobromophenol, parabromophenol. In case of bromine water, we get one product, that is 2,4,6 tribromophenol. That is about reaction with bromine. Next reaction is coal-base reaction. This is also very important reaction because this is named reaction, one of the named reaction, coal-base reaction. In this case, initially phenol reacts with NaOH, then we get sodium phenoxide. When this sodium phenoxide reacts with HCl and CO2, then this sodium is replaced by H plus and it is removed with Cl as NaCl. And this CO2 replaces one hydrogen ortho portion. Again that hydrogen combines with CO2. Finally COOH appears. That COOH appears at ortho portion of phenol. I repeat that point once again. Initially this phenol reacts with NaOH, then sodium phenoxide will obtain. This sodium phenoxide reacts with HCl initially, then that HCl replaces Na and that Na removed as NaCl and H comes instead of sodium. That means that H plus replaces sodium. Finally OH comes here. After that, this CO2 combines with the hydrogen which is present at ortho position, and COOH will obtain that COOH again attack at ortho position. Finally we get this compound. That compound name is called salicylic acid. Salicylic acid, its IUPAC name is what? 2-hydroxybenzoic acid. Because here two functional groups are present, out of them COOH is higher priority, it is having more prior functional group, so that it is considered as secondary suffix, it is considered as prefix. So number starts from here 1, 2 to hydroxybenzoic acid. So this is about coal base reaction. In coal base reaction, two steps are present. In first step, sodium phenoxide is formed. When it is treated with HCl and CO2, then we get salicylic acid. That's it. Next one, Reimer-Tiemann reaction. This is also very important reaction because it is also one of the named reaction. In this case, when phenol reacts with chloroform and NaOH, when phenol reacts with chloroform and NaOH, then we get salicylaldehyde. That means this is the H and one O. Out of 3 oxygens, 1 O comes at ortho position, then 3 NaCl will be removed along with H2O. That is called Reimer-Tiemann reaction. Here one important point is there, that is in that reaction its name is dichlorocarbene, that is acts as electrophile, nothing but reaction intermediate. That is very important reaction. What is reaction intermediate in Reimer-Tiemann reaction? That is what is reaction intermediate? Dichlorocarbene. Its formula is CCl2. You may think that where is CCl2 here? Here for this reaction mechanism is there, no need to discuss about that mechanism. If you in that mechanism reaction, this CCl2 will form when this CHCl3 reacts with NaOH. In first step of its mechanism, this will be formed. That acts as what? Electrophile. That is also called reaction intermediate. That is very important bit. Next reaction, oxidation. When phenols undergoes oxidation in the presence of sodium dichromate and H2SO4, then benzoquinone will be formed. Next, Williamson's synthesis. In that Williamson's synthesis, when you take sodium phenoxide, when this sodium phenoxide reacts with the methyl chloride, then we get methoxybenzene. That is also called inosol by removing NaCl. So these are the reactions of phenols, nothing but chemical properties of phenol. In next video we will discuss about acidic nature of phenols. Thank you.